Hello everyone, in this video we're going to do a review compilation type video for a unit in Algebra 1 that would be covering topics such as writing linear functions. So we'll jump right in. We're going to solve about 20 questions. You can use this as kind of a study guide review for a unit such as this. So here we go. Number 1 says write an equation of the line with a slope of -1/2 and a y-intercept of 8. So here they're just testing us on do we know what slope-intercept form is, which is y equals mx plus b, where m is our slope and b is the y-intercept. So on this type of question, we're just taking those values, plugging them in for m and b, and we have our equation. So we would have y equals -1/2 x plus 8, and that would be our equation. Number 2, write an equation in point slope form of the line that passes through the point -3, 4 and has a slope of -2. So now, still a linear function, but we're looking at a different form, not slope-intercept, but point slope. So point slope is y minus y1 is equal to m times x minus x1. And now we're going to plug in our point, which would be x1, y1, and our slope, which once again is m. And for this one, it says write it in point slope form. So we can easily simplify into slope-intercept, but we're not going to do that on this question. So y is 4, so it'd be y minus 4 is equal to m is -2, and then x minus -3, because our x value here was -3. But instead of writing minus -3, we're going to write that as plus 3. Because we know that when we subtract a negative, that's like adding a positive. So we've kind of simplified that to make it look a little neater. All right, number 3. Write an equation of the line that passes through -1, 6 and is parallel to the line y equals 3x plus 4. So here the key word is parallel. We need to understand or remember that parallel lines have the same slope. So if this line has a slope of 3, my line needs to also have a slope of 3. So we're going to start off with y equals 3x plus b. And now we're going to figure out what b is. What is the y-intercept when the line passes through -1, 6? So you could use point slope here. I just like to use slope-intercept because that's what I'm going to finish with. So I'm going to take y, which is 6, plug it in for y. -1, which is x, plug it in for x. And now we're just going to simplify this or solve it for b. So this would be 6 is equal to 3 times -1 is -3. Then we add 3 to both sides, so we get b is equal to 9. So now our slope was 3, our y-intercept is 9, so our equation would just be y equals 3x plus 9. Okay, so just a quick check to make sure we're at least on the right track of having the right answer. Our slope should be 3 for sure, right? Because that's what parallel lines are. And our y-intercept just should not be 4 because our original line was 3x plus 4. And we want a line to be parallel. We don't want the exact same line, right? So just kind of an easy way to check. All right, number 4, write an equation of the line that passes through 4, 2 and is perpendicular to the line y equals -4x minus 5. So now here we're talking about perpendicular, which our slopes are not the same. They are opposite reciprocals, which means if this line has a slope of -4, the opposite of -4 is 4. The reciprocal of 4 would be 1/4. Okay, so now one line has a slope of -4. Its perpendicular line would have a slope of negative opposite 1/4, opposite reciprocal. Okay, or sorry, the original was -4. Our perpendicular line would be 1/4. We started with negative, opposite of negative is a positive. So now we're going to write y equals 1/4 x plus b, and we're going to do the same process. We're going to plug 2 in for y, we're going to plug 4 in for x, and now we're going to solve. So 2 equals 1 plus b, because 1/4 of 4 is like 4 divided by 4, so that's 1. Subtract 1, so b is 1. So we have y equals 1/4 x plus 1 would be our equation that is perpendicular to -4x minus 5. All right, number 5 says use a graphing calculator to find an equation of the line of best fit for the data in the table. So for this problem, I'm going to go ahead and bring onto the screen right now my graphing calculator that is the online version so that you can see what I'm doing. But then you could easily do this in your handheld calculator, your TI-84 Plus CE. So go over to the calculator. First thing I'm going to do is push stat, and I'm going to hit enter because we want to type in our values. So this here is L1, list 1. We're going to type in our x values, which look like 0, 1, 2, 3, 4, 5, 6, and 7. So I'm going to do those 1, 2, 3, 4, 5, 6, 7. 6, 7. Okay, so for y, we're going to type in our y values. So -8, -8. Oh, pushed the wrong button there. Let's go back to stat and edit. All right, down here, -8. Good. And we got -2, sorry, -5, -2, -1, another -1, and then 2, 5, and 8. 2, 5, 8. All right, so we have our information there. And so now we can go ahead and graph it. If we graph it, we want to make sure on y equals that our plot is highlighted. So I'm going to go up to plot 1 and hit enter to turn that on. Now I hit graph and we see our scatter plot there. So we had 8 points, 1, 2, 3, 4, 5, 6, 7, 8. So that's good. So now at this point, we want to have our calculator find what's called linear regression, which is also line of best fit. So we're going to go back to stat, but this time we want to go over to calculate, and we want option number 4, LIN, linear, REG, regression. And then AX plus B looks like MX plus B. We want it to be in slope-intercept form. So we hit enter there, we go down to calculate, and we have our equation. So A is our slope. Let's round this to the nearest tenth. So that's going to be 2.1. So y equals 2.1x, and then it looks like the y-intercept is -7.5. So there's our equation. Okay. Now, it doesn't ask us, but we can talk about the correlation coefficient, which is the R value. So it looks like R is 0.980, which just means we're going to have strong positive correlation. Okay, because remember on that R scale, right, -1 to +1, strong negative to strong positive, and then in between there we can get weak positive, weak negative, but in this case it is very close to 1, so we're going to say it's strong positive correlation. All right. Okay, for number 6, it says we're going to write an equation for the nth term of the arithmetic sequence, -6, -2, 2, 6, and then find the 25th term. So we want to start off and say a sub n equals a sub 1 plus n minus 1 times the common difference. So a sub n equals, the first term is here, -6. We leave n minus 1. The common difference is what are we adding or subtracting to get to the next term. And it looks like we're adding 4. So we're going to put a 4 here. So now we have a sub n equals -6 plus 4n minus 4. So a sub n equals -6 minus 4. So 4n minus 10 would be our nth term equation. And now we want to find a sub 25. So we plug in 25 for n. A sub 25 would be 4 times 25 is 100 minus 10. So the 25th term of the sequence would be 90. And that's how we can do number 6. All right, number 7 brings us to a scatter plot. And we're just interpreting the scatter plot. So it says, what is the weight of the person who is 73 inches tall? So 73 would be here. So that looks like this point here. And that's going to be 170 pounds. What is the height of the person who weighs 135 pounds? Well, that'd be here. So that looks like that point, which is 66 inches. Very nice. All right, number 8. The equation y equals 6x plus 4 models the data below. Is the equation a good fit? Calculate the residuals and make a scatter plot of the residuals. So here we have to remember how to find a residual. So the residual is the difference of the data point and the corresponding y value found using the model or the line of fit. Okay, so we're going to kind of extend our table here. And once we find that, then we can subtract those values. This is going to be our residual here. Sorry for the messy writing. Let's extend those down. Okay, so if we zoom in here, we're going to take these x values and we're going to plug them in here. The result, we're going to put in this column here, okay, or that row. So for 1, 6 times 1 is 6, 6 plus 4 is 10. 6 times 2 is 12, 12 plus 4 is 16. 6 times 3 is 18, 18 plus 4 is 22. 6 times 4 is 24, 24 plus 4 is 28. 6 times 5 is 30, 30 plus 4 is 34. 6 times 6 is 36, plus 4 is 40. 7 times 6 is 42. 42 plus 4 is 46. 6 times 8 is 48. 48 plus 4 is 52. 6 times 9 is 54. 54 plus 4 is 58. Okay, so now we'll switch up our color, and now we're going to find our residual. So the residual is the y value from the data point, which is the column that has the pink arrow next to it, the second row, minus the column that has the blue arrow. So 13 minus 10, 3. 14 minus 16, negative 2. 23 minus 22 is 1. 26 minus 28 is negative 2. 31 minus 34 is negative 3. 42 minus 40 is 2. 45 minus 46 is negative 1. 52 minus 52 is 0. And 62 minus 58 is 4. Now, the scatter plot means we're going to plot these points, x, comma, residual. So let's go over here. So now we have 1, 3, 2, negative 2, 3, 1, 4, negative 2, 5, negative 3, 6, 2, 7, negative 1, 8, 0, and 9, 4. All right, so now, if this is a good fit, then our points should be more or less evenly dispersed about the horizontal axis. And we see that here because the horizontal axis is here, that's our x-axis. We have 3 points above, 4 points below, 1 on the axis. That's great. So, is it a good fit? We would say yes, it is a good fit because those scatter plot, or those residuals, the scatter plot of the residuals, are evenly dispersed about that horizontal axis. So yes, it's a good fit. All right, number 9. Graph the first 4 terms of the arithmetic sequence, negative 3, negative 1, 1, and 3. So now remember when we're graphing a sequence, we always start with x value of 1 because when we're looking at those numbers, it's the first term, second term, third term, fourth term, so on and so forth. So this is going to be 1, comma, negative 3, 2, negative 1, 3, 1, and 4, 3. Okay? So now the purpose of this is to show us that that those points are in a line. So does the graph represent a function? We would say yes. It actually represents a linear function. Now it says, what are the next 3 terms? Well, it looks like we're adding 2 each time. So that looks like it would be 5, 7, and 9. So that would be our next 3 terms. It doesn't tell us to graph those, but if we wanted to, we could. But we'll stick with that. Okay. All right, number 10. Write a piecewise function for the graph. So piecewise, we're going to start off and say f of x equals, and open our bracket there. Let's go from left to right. So let's do this piece first. It is a horizontal segment, or ray, I guess, that goes through negative 3. So that would just be y equals negative 3 if x is less than or equal to 0. Less than or equal because that dot was shaded in, and 0 because it has an x value of 0 where that dot is located, and then less than because we're going to the left of 0. All right, this piece here, it looks like we have a negative slope, so down 1, 2, 3, and right 1. So that's going to be negative 3x, and then it looks like our slope is, or excuse me, our y-intercept is 3. So negative 3x plus 3 if x is greater than 0. Greater than because it's an open circle and we're going to the right, and that x value where that point is 0. All right, let's do another one, number 11. So this one's a little bit different because notice that our points here, they stop when x is 4. So this 0 up here that we did, that's going to now be 4 in this question. All right, so let's say f of x equals, all right. And once again, let's go from left to right. So let's clean that up a little bit. So we're going to go with this line here. And it looks like our slope is down 1, right 1, so negative 1. And the y-intercept is 0, so that's just negative x. If x is less than 4. So open circle, and we're going to the left of 4. So that's what our domain restriction would be. All right, for the next piece, it looks like our slope is also negative 1, so down 1, right 1, so negative x. But we do need to figure out what the y-intercept would be. It doesn't go to the y-axis, but we have to write what b is, what the y-intercept would be. So if we just imagine it, it looks like, we're going up 1, left 1, right? So up, left, up, left, up, left, up, left, right? So that point would be there, which would be plus 1. And that's if x is, let's clean up our graph a little bit, greater than or equal to 4. Open circle, going to the right of 4, so greater than or equal to 4. All right. Number 12, a coffee shop sells 4,000 iced Americanos in 2019. They sell 5,329 iced Americanos in 2024. Write a linear model that represents the number y of iced Americanos the coffee shop sells x years after 2019. When it says years after 2019, that means the amount we sold in 2019 would be the initial or the starting amount, which would be like a y-intercept, which means x would be 0. So this would be like 0, 4,000. 2024 would be 5 years later, so 5, and 5,325. So if we want to write a linear model, that's just slope-intercept form, so we need to find the slope because we already know the y-intercept is 4,000 because that's what we started with in 2019. So let's do 5,325 minus 4,000, and then 5 minus 0. So that's going to be 1,325 divided by 5, and since we have our calculator here, 1,325 divided by 5 is 265. So we get 265 would be our slope. We knew that 4,000 was the y-intercept, so we have y equals 265x plus 4,000. So what does that mean? Essentially it means that we started in 2019 with 4,000 iced Americanos, and each year we're selling 265 more, not more, but we're selling 265 each year, right? So we're going up by a steady amount, so that looks good. All right, number 13, write an equation of the line that passes through the given point and is perpendicular to the line shown. So perpendicular means when you have opposite reciprocal. So let's find the slope here. If we look at this point and then this point, it looks like 1, 2, 3, 1. So it looks like the slope here is 3. So our line needs to be the opposite reciprocal, which would be negative 1/3. We want to go through 3, negative 2. So let's figure out what our y-intercept would be if we use these values. So y is negative 2 and x is 3. So this would be negative 2 is equal to negative 1 plus b. We add 1. So it looks like b is negative 1. Okay, so now let's double check that. That looks good, right? Negative 1. Perfect. Okay, so now we would say y equals negative 1/3 x minus 1, and that would be our perpendicular line. Number 14, 1 year after buying a sunflower, it is 3 feet. Each year it grows 2 feet. Write a function that represents the arithmetic sequence, and then how long will it take the sunflower to reach its maximum height of 19 feet. So they're telling us it's an arithmetic sequence, which is great. So we could say a sub n equals a sub 1 plus n minus 1 times the common difference. We can see that the first term would be 3, and they told us that it's growing at a rate of 2 feet per year. So that'd be our common difference, okay? So now we can say a sub n equals 3 plus 2n minus 2. So we get a sub n equals 2n and plus 1. Okay, so now let's not put a box around that just yet. Actually, let's do that because they wanted us to write the function. So let's change a sub n to f of n just because it's a function. All right, so we have that. And then it says, how long will it take for it to 19 feet? Well, we would go 19 is equal to 2n plus 1, subtract 1. So 18 equals 2n. So it looks like it'll take 9 years for it to get to that height. Very nice. All right, number 15, piecewise function. We want to graph it and describe the domain and the range. So it looks like we have negative 2x plus 3 if x is less than 0. So we're going to the left of the y-axis, open circle because of our inequality symbol. So plus 3, go ahead and zoom in a little bit here, make it easier for us. So plus 3. And then our slope is negative 2. So we're going to go up 1, 2, right 1, 1, 2, 1. And we can draw our line there. So there's that piece. So we're going downhill from left to right. And then we have x minus 4 if x is greater than or equal to 0. So close circle on 4, and the slope is just 1. So now we can make our line here. And that looks pretty good. Okay, so our domain here would just be all real numbers. That's a symbol that means all real numbers because we go left forever, go right forever. Our range, though, would be y is greater than or equal to negative 4 because this point right here is our lowest point, and it's a closed circle, so we're including negative 4, and then we go up from there. All right, number 16, write the step function. So these are pretty simple. We just have to know how to read it, right? So from here, we're going from 2 to 4, and this piece, right, or this step is equal to -2. So it would just be -2, comma, if, and now we're going to write our domain restriction. So here we have a closed circle on 2, and so we're going to say 2 less than or equal to x less than 4. So how we would really read that is we would say x is greater than or equal to 4 and 2 and less than 4. And the good thing about step functions is once we have that first step, then the rest of them are pretty simple. They are just kind of a repeated pattern of that first one. So then we have -1, then we would have 0, and then we would have 1. Now all of these are if, and now we're going to go up from there. So for -1, we're 4 to 6, and then for 0, we're 6 to 8, and then for 1, we are 8 to 10. All right. Okay, number 17, graph the sequence, and then does it represent a function? So we did one of these earlier, so very similar. We're going to start with an x value of 1, so 1, -4, 2, -1, 3, 2, 4, 5. All right, so does it represent a function? Yes, it should, because it's arithmetic and it's going to mimic a linear function because these points are technically in a line. We're not going to connect these like this, but notice if we did, they would all lie on that line. All right, number 18. A piecewise function is defined by f of x equals x minus 1 if x is less than 3, and f of x equals -x plus 5 if x is greater than or equal to 3. So write the function as an absolute value function. So this question is kind of difficult, but it's going to be a whole lot easier if we'll graph it. So let's graph the piecewise first, and then we can rely on maybe some past knowledge of how to write an absolute value graph as a function. So we have x minus 1 if x is less than 3. So -1 would be here. Let's put a dot there at our y-axis, or excuse me, our y-intercept for this piece here. And then the slope is 1. So we're going up 1, right 1, up 1, right 1, up 1, right 1. But we're going to stop here at 3. And it's actually going to be an open circle because of this symbol right here. So now we can make this here. Let's go to about right there. And that's kind of that first piece. The next one we have -x plus 5, but it's only to the right of 3. It is or equal to, so we could actually go ahead and shade this dot in. And now our slope is -1. So we're going to go down 1, right 1, down 1, right 1. You might be asking, how did you know to start at the end of the other point? But really the reason we're doing that is because our domain restriction went to 3. So we could go all the way up to 3, but not past it. So that's why we did that. Okay, so now we can connect these points here. That's a little bit low. Let me see if it'll let me move that up. There we go. That's better. Okay. So now essentially we have an absolute value function here that we need to write the function for. Well, if we think about the vertex, that's going to help us to write it in vertex form. The vertex is here. That's at 3, 2. Okay. So remember we have y equals a times x minus h plus k. So we can go ahead and plug in 3 there and 2 there. And we need to find out a. Well, a is positive if we're opening up, negative if we're opening down. So we know it's going to be negative. And remember for our parent function for an absolute value, we go out 1, up 1. Or if we reflected it, out 1, down 1, out 2, down 2. And that's what we're doing here. So we actually don't have a stretch or a shrink because we go out 1, down 1, out 2, down 2. So now that tells us that a is just -1. So we would say y equals -x minus 3 plus 2, and that would be our answer for number 18. All right. Number 19, the graph represents the cost of joining Planet Fitness Gym. The cost of joining Anytime Fitness Gym is represented by a parallel line to the graph that passes through the point 10 to 40. We want to write an equation for Anytime Fitness. Well, we want to know what the slope is for this line. So let's go ahead and find 170 minus 90 and then 7 minus 3. All right, so this is going to be 80 over 4, which is 20. So now we know that our line for Anytime Fitness needs to be 20x and then plus b. Here's our point. We've done this a couple times in this video. So we're going to plug 240 in for y. We're going to plug 10 in for x. So we get 240 is equal to 200 plus b, which once we subtract, we're going to see that b is 40. So we have y equals 20x plus 40 for our equation for Anytime Fitness. All right. And our last question, we want to complete the table for this arithmetic sequence. So remember, for arithmetic sequence, right, it is very similar to a linear function, which means the x values are like the position, the y values are like our terms. So if we are trying to figure out what the common difference is, it's very similar to finding the slope. So when you're looking at a table like this, look at two terms that you know both the position and the term. So that's here and here. I guess my arrow should have been up, right there and there. So now let's take those and act like they're coordinates. So this would be like x and y. So let's do 164 minus -10, and then 30 minus 1. So this is going to be 164 plus 10, so 174. And then 30 minus 1 is 29. So let's just do 174 divided by 29, and we get 6. So now what 6 tells us there is that our common difference is 6. So now here's where we want to go ahead and write our nth term equation, and then we can just fill in whatever we need, right? So we're going to say a sub n is equal to the first term plus n minus 1 times that common difference. So we get a sub n equals -10 plus 6n minus 6, -10 minus 6, so we have a sub n equals 6n minus 16. Okay, now we're going to use this to fill in what we don't know. So for this first box, we'll call this box number 1. We know that the term is 8, but we don't know the position. Okay, remember position is n, right? So for this one, we're going to say, we'll call this number 1 here, 8 is equal to 6n minus 16, right? So now we can add 16. So we get 24 is equal to 6n divided by 6. So n would be 4. So this would be the fourth position in the sequence. 8 would be the fourth term, okay? Now for the next one, we know that n is 7. So we'll call this box number 2. So we'll go over here for box number 2. So now we're just going to find a sub 7. So that's going to be 6 times 7 minus 16. So that's 42 minus 16, which should be 26. So now we know that's 26. Now for the next one, we'll call it box number 3. Okay, we'll do it right here. This one is very similar to number 1. We know the term, but we don't know the position. We don't know n. So let's do 74 is equal to 6n minus 16. Let's add 16. So we're going to get 90 is equal to 6n divided by 6. 90 divided by 6 is going to give us 15. So n is 15. So the 15th term of the sequence is 74. All right, last one is number 4. This one, box number 4, we need to find a sub 21. So that's going to be 6 times 21 and then minus 16. So that's going to be 6 times 20 would be 120. So 126, 21 times 6, 126. 126 minus 16 is going to give us 110. Very good. All right. So hope that helps. Give you kind of a review, video compilation for a unit in Algebra 1 about writing linear functions.